Okay, so again, good afternoon to everyone. Our subject is CS6201A for computer organization and architecture. So before we proceed, let us again define what is computer organization and computer architecture. So when we say computer organization and architecture, is the study of internal working and structuring and implementation of computer system. So organization of computer system is the way of practical implementation which results in realization of the architectural specifications of a computer system. The computer architecture is concerned with the way hardware components are connected together to form a computer system. Whereas the computer organization is concerned with the structure and behavior of a computer system, so as seen by the user. So right now, our topic is about computing system. So this is week 2. So computing systems or computer system. So it is a system of one or more computers and associated software with common storage. So a few examples of computer systems that we use today are mobile phones, keyboards, touch screens, barcode scanners, touchpads, etc. So computer systems that we come across in our everyday life. In a library systems, we have emails, have yung mga holiday bookings, shop, and the internet. So the computer, along with a additional hardware and software, so together it's called a computer system. So computers have two kinds of components. We have the hardware and the software. So hardware consisting of its physical devices like CPU, memory, bus, storage devices, whereas software, it consists of the programs. It has operating system, applications, and utilities. So the hardware represents the physical and tangible components of a computer. So the components that can be seen and touched. So it includes the physical parts of a computer. So simply, a computer hardware is the physical components that a computer system requires to function. So examples of hardware are the following. We have input devices like keyboard, mouse, okay, etc. In output devices, we have printer, monitor, etc. And then we have also the secondary storage devices, hard disks, the CDs and DVDs. And internal components like CPU, the motherboard, RAM. And then in a software, when we say a software, it is a set of programs which designed to perform a well-defined function. So a program, it is a sequence of instructions written to solve a particular problem. So it is an instructions that tell a computer what to do. So software comprises the entire set of programs, like procedures and routines associated with the operation of a computer system. So the term was coined to differentiate these instructions from hardware, the physical components of a computer system. And of course, software refers to a programming code that is executed on the computer hardware that facilitates the completion of tasks by a computer. So examples of a software include the operating systems, which allow for easy use of computers' processing power. So as well as the applications like Notepad and Firefox. Okay. So the two types of software, the system software and the application software. So the system software is designed to provide a platform for other software. So examples of system software include the OS, the operating system like the Mac OS, Linux, Android, and Microsoft Windows, like computational science software, game engines, search engines, industrial automation, and software as a service applications. Whereas the application software is a type of computer program that performs a specific personal, even educational, and business function. So each program is designed to assist the user with a particular process, which may be related to a productivity, to a creativity, and or communication. So application software, app for short, it performs a specific task for an end user. So what is the difference between system software and the application software? So a system software, it is designed to manage the resources of the computer system, like memory and process management and many more. Whereas the application software, it is designed to fulfill the requirements of the user for performing specific tasks. So computers can be broadly classified by their speed and computing power. So the first type of computer, we have a personal computer. It is a single user computer system having moderately powerful microprocessor. Second type, we have workstation. It is also a single user computer system similar to personal computer, however, has a more powerful microprocessor. Then third type, we have mini computer. It is a multi-user computer system capable of supporting hundreds of users simultaneously. And then fourth, we have mainframe. It is a multi-user computer system capable of supporting hundreds of users simultaneously. So software technology is different from mini computer. And then fifth type of computer, we have supercomputer. It is an extremely fast computer which can execute hundreds of millions of instructions per second. So all types of computers follow the same basic logical structure and perform the following 5 basic operations for converting raw input data into information useful to their users. So the first operation of computer, we have take input. So it means the process of entering data and instructions into the computer system. Then second operation, we have store data, saving data and instructions so that they are available for processing as and when required. Then third operation of computer, we have processing data. It means performing the arithmetic and logical operations on data in order to convert them into useful information. Then for operation, we have output information. So it means the process of producing useful information or results for the user, such as a printed report or visual display. Then PIP operation, control the workflow. It directs the manner and sequence in which all of the above operations are performed. So those are the computer's operation. We have take input, store data, processing data, output information, and control the workflow. Then we have also the functional units of computer. So we have input unit, the output unit, the central processing unit, which has a LU and control units, the arithmetic logic unit, and control units. And then we have memory and bus structure. So those are the main functional units of a computer system. So the figure shows the big picture, which has a processor, the input, the control, the memory, the arithmetic logic unit, the output. Okay, so since 1946, all computers have had 5 components. So the first function of the computer system, we have input unit. So in input unit, it converts the external world data to a binary format, which can be understood by a central processing unit. So this unit contains devices with the help of which we enter data into the computer. So this unit creates a link between the user and the computer. So the input devices translate the information into a form understandable by the computer. In computing, an input device is a peripheral, okay, devices, a piece of computer hardware equipment, so used to provide data and control signals to an information processing system, so such as a computer or other information appliance. So examples of input devices include, first we have keyboard, okay, mouse, joystick, light pen, trackball, scanner, the graphic tablet, microphone, the magnetic ink card reader, the optical character reader, barcode reader, and the optical mark reader. So those are some of the important input devices. Then another functional unit, we have output. So the output converts the binary format data to a format that a common man can understand. So the output unit consists of devices with the help of which we get the information from the computer. This unit is a link between the computer and the users. Output devices translate the computer's output into a form understandable by the users. So after processing of data, it is converted into a format, okay, which humans can understand. So after conversion, the output units displays this data to users. So following are some of the important output devices used in a computer. So it includes the following, like monitors. We have a graphic plotter, screens, printers. Also, we have speakers, the LED or the LED, the LCD, and many more. So those are some of the important output devices. So it is any piece of computer hardware equipment which converts information into a human readable form. So it can be text, so it can be graphics or audio and video. But some of the output devices are visual display units. Okay, so either monitor, printer, graphic output devices, speakers, and many more. And then another functional unit, we have the central processing unit, which is the CPU, is considered as the brain of the computer. So the CPU performs all types of data processing operations. So it stores data, intermediate results, and instructions or program. It controls the operation of all parts of the computer. So the computer central processing unit is the portion of a computer that retrieves and executes instructions. So the brain of the computer system. So of course, it consists of an arithmetic logic unit, the memory unit, and control unit. The central processing unit consists of the following features. Okay, so figure shows an example of a central processing unit. So it is also called a central processor, a main processor, or just a processor. It is the electronic circuitry that execute instruction comprising a computer program. So some features of the CPU. So first, CPU is considered as the brain of the computer. The CPU performs all types of data processing operations. It stores data, intermediate results, and instructions like program. And it controls the operation of all parts of the computer. So those are some features of the central processing unit. So the CPU, the brain of the machine, responsible for carrying out computational tasks, contains the arithmetic logic unit, control unit, and registers. The arithmetic logic unit performs arithmetic and logical operations. The control unit provides control signals in accordance with some timings, which in turn controls the execution process. Register stores data and result and speeds up the operation. So it is the electronic circuitry within a computer that carries out the instructions of a computer program by performing the basic arithmetic logical control input and output, the I/O operations specified by the instructions. So an example of operation of CPU, like for example, add R1 and R2. So T1, of course, enable the R1, and the transaction or T2 enable the variable R2. And then the T3 enable, of course, the operation, the ALU for addition operation. And then the T4 enable output, okay, of ALU to store results of the operation, okay. So a simple process operation of the CPU, the input, process, and output of the R1, R2, then get the operation, enable the ALU for arithmetic operation, for addition or subtraction, division, and multiplication, and then get the output, the results of the operation. So the CPU itself has following three components. So you have the memory or the storage unit, the control unit, and the arithmetic logic unit. So the memory or the storage unit. So this unit can store instructions, data, and intermediate results. So this unit supplies information to other units of the computer when needed. It is also known as internal storage unit or the main memory or the primary storage or random access memory, which is the RAM. So its size affects rather speed, power, and capability. So the primary memory and the secondary memory are two types of memories in the computer. So the functions of the memory unit are, first, it stores all the data and the instructions required for processing. Second, it stores intermediate results of processing. Third, it stores the final results of processing before the results are released to an output device. And fourth, all inputs and outputs are transmitted through the main memory. So the memory is the process of storing and recalling information. So it describes the length of time something is retained in the human mind or in the human mind. So refers to the equation of a short term. The data storage is the component of your computer that allows you to store and access data on a long-term basis. So the memory stores data, results, and programs. So the two classes of storage, we have the primary and the secondary storage. So two types are RAM or the read-write memory and the ROM, read-only memory. So the ROM is used to store data and program. So it's not going to change. Whereas the secondary storage is used for bulk storage or mass storage. So a memory is just like a human brain. So it is used to store data and instructions. So computer memory is the storage space in the computer where data is to be processed and instructions required for processing are stored. So the memory is divided into a large number of small parts called cells. So each location or cell has a unique address which varies from 0 to memory size -1. For example, if the computer has 64 keywords, then this memory unit has 64 multiplied by 1024 equals to 65,536 memory locations. So the address of these locations varies from 0 to 65,535. The memory is the primarily of three types. We have the cache memory, the primary memory or the main memory or the secondary memory. So those are the primary types of the memory. Okay, so the first type, we have the cache memory. So figure shows an example of a cache memory. It is a very high-speed semiconductor memory which can speed up the CPU. So it acts as a buffer between the CPU and the main memory. So it is used to hold those parts of data and program which are most frequently used by the central processing unit. So the parts of data and programs are transferred from the disk to cache memory by the operating system, from where the CPU can access them. So cache memory, also called a cache supplementary memory system, that temporarily stores frequently used instructions and data for quicker processing by the central processing unit of a computer. So cache holds a copy of only the most frequently used information or program code stored in the main memory. So as shown in the given figure, it is a small size type of volatile computer memory. So that provides a high-speed data access to a processor and stores frequently used computer programs, applications, and data. So a temporary storage of memory. Cache makes data retrieving easier and more efficient. Then another type of memory, we have the primary memory or the main memory. So figure shows an example of a primary memory. It holds only those data and instructions on which the computer is currently working. So it has a limited capacity and data is lost when power is switched off. So it is generally made up of a semiconductor device. So these memories are not as fast as registers. The data and instructions required to be processed resides in the main memory. So it is divided into two subcategories, the RAM and ROM, which is the random access memory and read-only memory. So the primary memory is a computer memory that a processor or computer access the first or directly. Also allows a processor to access the running execution applications and services that are temporarily stored in a specific memory location. So primary memory, also known as the primary storage or the main memory. The characteristics of main memory. So these are semiconductor memories. It is known as the main memory. Usually volatile memory. Data is lost in case power is switched off. It is the working memory of the computer. Faster than secondary memories. A computer cannot run without the primary memory. So those are some characteristics of the main memory. And then next, another type of memory, we have secondary. So this type of memory is also known as external memory or non-volatile. So it is slower than the main memory. So these are used for storing data and information permanently. So the central processing unit directly does not access these memories. Instead, they are accessed via input-output routines. So the contents of secondary memories are first transferred to the main memory, and then the CPU can access it. So figure shows an example of the hard disk, the HDD. We have also the compact disk, ROM, and the DVD. So the secondary storage memory is also termed as external memory and refers to the various storage media on which a computer can store data and programs. The secondary storage media can be fixed or removable, of course. So fixed storage media is an internal storage medium like hard disk that is fixed inside the computer. So example of the secondary memory, we have the hard disk, the floppy disk, the magnetic tapes, no? And many more. Whereas the primary memory, we have the RAM, ROM, cache memory, the EEPROM, and the registers. We have the characteristics of the secondary memory. So first, these are magnetic and optical memories. Second, it is known as the backup memory. Third, it is a non-volatile memory. Fourth, data is permanently stored, even if power is switched off. Fifth, it is used for storage of data in a computer. Then sixth, computer may run without the secondary memory. And then seventh, slower than primary memories. So those are some of the characteristics of a secondary memory. So that is the difference, okay, between the primary memory, okay, and the secondary memory. So the primary memory, again, is also called internal memory, whereas the secondary memory is also known as a backup memory or auxiliary memory. Okay, so that is the difference between the two, the primary and the secondary storage memory. So the component of the CPU, we have also control unit. So this unit controls the operations of all parts of the computer, but does not carry out any actual data processing operations. So the control unit is a component of a computer's central processing unit that directs the operation of the processor. So in modern computer designs, the control unit is typically an internal part of the CPU. So with its overall role and operation unchanged since its introduction. The control unit is a component of computer CPU. So it is circuitry, okay, that directs operations within a computer's processor, yung ating CU. So the main functions of the control unit, first, it is responsible for controlling the transfer of data and instructions among other units of a computer. And also it manages and coordinates all the units of the computer. It obtains the instructions from the memory, interprets them, and directs the operation of the computer. It communicates with input-output devices for transfer of data or results from storage. And it does not process or store data. So those are the functions of the control unit. Whereas the arithmetic logic unit, when we say ALU, it is a combinational digital circuit that performs the arithmetic and bitwise operations on integer binary numbers. So this is in contrast to floating point unit, yung mga may decimal places, which operates on floating point numbers. So an ALU or the arithmetic logic unit performs basic arithmetic and logic operations. So examples of the arithmetic operations are addition, subtraction, multiplication, and division. Whereas in logical operations are comparisons of values such as net, and or. So those are the examples of the logical operations. Okay. So the ALU, the unit consists of two subsections. Again, we have the arithmetic section and the logical section. So the control unit works with a reference signal called processor clock. Okay, so the processor divides the operations into basic steps. So each basic step is executed in one clock cycle. So it means that the control unit works with a reference signal, okay, yung ating processor clock. So example, we have the T1 and T2. So the processor divides, okay, the operations into basic steps. So dinidivide yan ng processor into basic steps for R1 and R2. So each basic step is executed in one clock cycle, okay, which is the R2. So in arithmetic section, so the function of arithmetic section is to perform the arithmetic operations like addition, subtraction, multiplication, and division. So all complex operations are done by making repetitive use of the different operations. So the ALU, okay, performs the simple addition, subtraction, multiplication, division. Whereas the logical operations, so it is performed the logic operations such as comparing, selecting, matching, and merging of data. Comparing, let's say, greater than equal, less than equal sign, not equal. Whereas in logical operation, yung ginagamit natin sa ating programming using the and, or, and not. Okay? So it stores the program's instructions and data. And then another type of or another functional unit of computer system, we have bus structure. So ang bus, it is a collection of wires that connect several devices within a computer system. So when a word of data is transferred between units, all its bits are transferred in parallel. So a computer must have some lines for addressing and control purposes. So ang bus is a communication system in a computer architecture that transfers data between components inside a computer or between computers. So let's say a system bus has typically from 50 to hundreds of distinct lines. So where each line is meant for a certain functions. So napakadaming linya sa ating bus. So each line is meant for a certain function. So these lines can be categories into three functional groups. We have data lines, we have address lines, and control lines. Okay, so those are the three categories or three functional groups of a bus. And then we have also the important function of the computer. So all computers functions are, first we have the data processing, we have data storage, we have data movement, we have data control, okay, and nothing else. So the first function of computer, we have the data processing. So we all know that the data is an organized raw facts, okay, data into a meaningful information. So the data processing, we all know that it is the manipulation of data by a computer. So it includes the conversion of raw data. Okay, yung ating mga raw data converts into readable form. So it includes the conversion of raw data to machine readable form, flow of data through the central processing unit and memory to output devices, and formatting or transformation of output. So it means that any use of computers to perform defined operations on data can be included under the data processing. So lahat naman tayo familiar on data processing, okay? Like word processing. But computers were really developed for data processing. So the organization and manipulation of large amounts of numeric data, or in computer jargon, yung mga number crunching. Some examples of data processing are calculation of satellite orbits or weather forecasting. Then another function of computer, we have data storage. So again, it is the recording of information in a storage medium. The handwriting, phonographic recording, yung magnetic tape, and optical disc are all examples of data or storage medium. So it refers to magnetic, optical, or mechanical media that records and preserves digital information for ongoing or future operations. The data storage. Okay. Then next, another function of computer, we have data movement. So ang data movement, ito naman yung, it is the ability to move data from one place to another place. Or it is the ability to move data from one place in your organization to another through technologies, diba? That include the extract, that include the transformation, that include the load, the extract load, and then the transform, and also it include the data replication and change data capture. So primarily for the purposes of data migration and data warehousing ng ating data movement. So data movement instructions, it means move data from one place, called the source operand, to another place, called the destination operand. So the data movement instructions can be grouped into loads, into stores, moves, and immediate loads. So the load instructions move data from memory to a registers. And then another function of computer, we have data control. So data control, it means it is the management oversight of information policies for an organization's information. So it means in data control, it monitors and restricts the transfers of files containing yung mga sensitive data para ma-reduce the accidental data loss. Okay? So that is the data control. So those are some of the computer functions. The data processing, the data storage, the data movement, and data control.